Welcome friends, let's do this limit here as x approaches positive infinity, x minus ln x cubed minus 1, a nice little exercise. So first we have an ln and then we have just x. It seems like there's no way of combining them, but there is. And the other issue is what happens. Well, x goes to infinity, right? When x goes to infinity, this term x goes to infinity. It also means that this ln of x cubed here minus 1, that also goes to infinity. So we have that infinity minus infinity form, a competition. So we have to somehow eliminate that. So we'll say the limit as x approaches positive infinity, and then we write that x there in a more useful format. So we have an ln. We would like the x to also contain an ln in some fashion. So we can write ln of e raised to the x. That's allowed because ln and e are inverse functions. That's equivalent to just writing x. And then minus that ln of x cubed minus 1. Now, because we do have two natural logs, we can say the limit as x approaches positive infinity, and then just write that part as ln of e to the x over x cubed minus 1 this way. And then we continue working on this. All right, now, what can you do with the limit? We can bring the limit inside the ln function. It's pretty standard. So you can say the ln of the limit as x approaches positive infinity of this e raised to x divided by x cubed minus 1. Now, what happens in this case? Again, when x goes to infinity, e to the x goes to infinity, doesn't it? Okay? And then look, on the bottom, when x goes to infinity, and then x cubed minus 1 also goes to infinity. We have infinity over infinity. We know how to handle that, don't we? Just differentiate the top and bottom with L'Hopital's also ln of the limit as x approaches positive infinity, and e to the x is just e to the x differentiated. X cubed minus 1 is 3x squared. Now, well, let's see what happens in this case. When x goes to infinity, that means e to the x still goes to infinity, right? And then likewise with this bottom 3x squared. So 3x squared when x goes to infinity, that also still goes to infinity. It's still infinity over infinity. See? You have to differentiate again the ln of the limit as x approaches positive infinity, and this is e to the x divided by 6x. But again, the same issue. Here you can check it pretty quickly, right? It's going to be infinity over infinity still. Both of these go to infinity, so you can have the ln of the limit as x approaches positive infinity of e to the x over just positive 6. So what do we have now? Well, the top goes to infinity and the bottom is a 6, correct? So that's, of course, infinity. So in other words, we have ln of infinity, but that is infinity, which means that the value of the limit is infinity. The limit diverges. Leave a like and subscribe if you like math videos at this more advanced level.